Hello, Mr. Peterson here with some more physical science concepts. Today we're going to be talking about mixtures, and specifically solutions, colloids, and suspensions, and the difference that they have. If we notice right now, we can see that a mixture is when two or more substances are mixed together but are not chemically bonded. Usually we call this a physical interaction or a physical combination. There are different types of mixtures, such as the Kool-Aid Man. The Kool-Aid Man is a mixture known as a solution. If we look at the Kool-Aid Man, he kind of looks like one thing because the Kool-Aid all looks one color, but if we zoom in on that specific molecule, we'll notice that there's really actually food coloring, water, and sugar in the Kool-Aid Man. Now, if we look at salad, on the other hand, salad, you can tell the different parts. You can see where the tomatoes, where the olives, the onions, and lettuce and cheese are. So say I did not want cheese, I could very easily just pick the cheese out of my salad. Whereas in the Kool-Aid Man, if I didn't want food coloring anymore, it'd be a lot more difficult for me to separate. I could still do it, but it'd be a lot more difficult for me to do. The next thing we want to talk about are the differences between the two different types of mixtures. There are heterogeneous mixtures, which are suspensions, and you can see the different parts. So going back to our last example of salad, I could see that there's the cheese, onions, and lettuce in there. Or in this pile of M&Ms, I can actually take out the red parts if I wanted. So if I didn't want this red M&M right here, I could just take that out very easily. We're in the other version, or the other type of mixture, which is called homogeneous, means that it looks like one substance. So I cannot really just easily take the parts out. It might be a little bit more difficult, but I can still do it. The way I remember these, I think of the prefixes hetero and homo. The prefix homo means the same, and the prefix hetero means different. So when I see the heterogeneous, it makes me think of something that's different, and I can see the different parts of it. The next part we're going to talk about are solutions. Now solutions they look like they're one thing. They are homogeneous mixtures. I have a little video that I want to show you, and it's all about how salt dissolves in water. Because when we have salt water, we cannot tell where the salt is, and there's a reason for that. So let's watch along. So you can see here's a water molecule coming in, made of hydrogen and oxygen, and it comes in contact with this basically salt cube. So this is more than one molecule of salt. Okay, sodium chloride, you can see the different parts. Now, as we said earlier, that water is made of hydrogen and oxygen, so it has different charges. The hydrogens are charged positively and the oxygen is charged negatively. Same thing with the salt. The sodium is charged positively and the chlorine is charged negatively. So if we learned anything from Paula Abdul in the 80s, we learned that opposites attract. So the positive charges will be attracted to the negative charges. And that's what's happening in this video now. And they actually can pull each other away because they kind of like each other so much, or they're so attracted that they pull each individual salt particle out. So if we watch, we look, the opposite charges are attracted to each other and they pull the different parts apart. Now we watch as the water kind of destroys the salt or dissolves, or because salt is soluble, meaning that it dissolves in water, it pulls all the parts apart. So we can see this giant salt grain is now broken up into one specific part. The next thing, so if I was to zoom in, we can see there's salt and water. So as we said earlier, salt is a homogeneous mixture, or salt water, excuse me, is a homogeneous mixture because it's really composed of salt and water. So if we zoom in on each part, we can see the different parts that it's made of. Or in this video, we can see that it got broken up. All right. Some more things about solutions that we need to know are they cannot be filtered out. So I can see this coffee right here. I can look up here and I can see the coffee beans and the water, how it's all, but when I pour it through this filter, it comes through and it looks exactly the same because I cannot filter out the different parts of a solution. Also, solutions have different parts that are known as the solute and solvent, which means that they are dissolvable. The solute is what dissolves or is soluble in the water. So if I look here, I have the solute, which is dissolving. The solvent dissolves more. Also, the solvent is more than the solute. The solute is the less part. And they spread out to the point where they're all over the place. Once again, I look in this picture, if I have sugar water, I cannot see where the solute and solvent is, except for on the bottom when it first starts getting taken apart. And then eventually they will be divided so much that I cannot see the different parts. Lastly, we talked about the word soluble. So if I look at oil when I pour it in water, it is insoluble, means it does not dissolve, where this over here is dissolvable, so it does dissolve and create a different picture, or it creates a different substance that looks like it's composed of one, where the oil looks like it's only is composed of two things. There are some other things that we need to know about solutions, such as concentration. Are they diluted or are they concentrated? So if I look at these two pictures here, I can see there's differences between them. The one on the left being a little bit more dimmer or transparent, opaque, where the one on the right is very solid almost. You can see there's a lot more solute. This is the solute right here in this one than there is over here. So this solution over here is known as dilute because it has less solute, where this one is known as concentrated because there's much more solute. Now, I have an animation that I would like us to look at about solubility. Okay, and what it tells us is I have right here, I just have some water and I have some salt. So as I shake this salt shaker, salt falls out. Now as the salt goes into the water, it starts to dissolve. Now there's a thing known as solubility. And what solubility is it means that you get to a point where a substance or a solvent can no longer dissolve any more substance. So if I slowly shake some of the salt in, I'll get to the part where I've gotten to right now, where I notice there's some salt on the bottom that does not dissolve. That's known as solubility. I've reached the maximum amount of soluble solute. So if I put salt in, the more salt I put in, it doesn't matter. Okay, unless I add more water, it's not going to dissolve. So once I add more water, we can see some of that solute starts to dissolve and go away because I'm adding more. Now if I take away some water, I can see some of the solute goes with it, but as I add more solute, it does not dissolve because I have already reached the solubility of that substance. The other thing that solutions do not do is they do not scatter light. So if I shine a light, we'll notice it bounces off here and here, but that's the glass really that's reflecting the light, where it does not reflect as it goes through. The second type of mixtures are colloids, and colloids are mixtures of two or more things that appear to be one thing, but they can scatter light. They do not settle out. So if I look at this over here, okay, which is this example of scattering lights, I can see now when this light goes through, it scatters light in both substances. So these are both colloids. They look like they're one thing. They're not settling out, but they scatter light. Some examples of colloids are Jell-O, and that's how I remember what colloids are. I think of Jell-O, J-E-L-L-O, and Jell-O has two L's and an O in it, where colloid also has two L's and an O in it. Just like solutions, colloids cannot be filtered out, which means that if I did pour them through a filter, both parts would go through a filter. So if I could liquefy Jell-O and I poured it through a filter, it would go through a filter. Okay. Another example of colloid is milk. Okay. It will scatter light. It scatters light to the point of that it really doesn't even pass through like it would over here. The last type of mixture that we're looking at are suspensions. And those are two or more things that are put together to make a mixture, but you can actually see the different parts. These are known as heterogeneous. So if I look at this snow globe, I can see the little particles of the snow scattered throughout it, and I can also see the liquid solvent, or in this case not really a solvent, but the liquid that is in that. I can also see, if I pour them through a filter, certain things get stuck in the filter. So here, if I'm making coffee, I have the coffee up here. It's getting stuck in the filter. It's not going through, but some things can go through. So the water is falling through and it's making my coffee. And that's how I make the coffee, is I get caught in the filter. The last thing we want to look at is suspensions do actually scatter light. So here's my colloid and solution suspension. They scatter light. When the light goes through it, they get the light scattered. Over here, there is not light being scattered. So you can actually see the light going through. Here's another picture of a suspension I just wanted to show you that I think does a pretty good job of showing the different parts. Now the last thing I wanted to show you is how can I tell what mixture I have. So this is the flow chart that Mr. Peterson has kind of in my brain. And I really, really think this is very, very useful. So can you see the different parts or can it be filtered? And if it can, yes, then that's a suspension. If it cannot, then I ask myself, does it scatter light? And if it does scatter light, well, then it's a colloid. If it does not scatter light, then it's solution. I also have this arrow right here to show that suspensions also do scatter light. But if I can separate it through a filter, it's a suspension regardless. Now, do not forget to see the 7th grade physical science website if you need some more help for other links and videos and things like that that can help you. Thank you and have a good day.